Hello, welcome back to my channel. Today we will continue on chapter 6, alternating current. In this video, we are going to discuss on 6.2 root mean squared, RMS. Okay, so before we start, let us have a look first. What is the equations that we will use for this subtopic? Okay, so we will use I RMS is equal to I naught over sub 2 and V RMS is equal to V naught over sub 2. Okay, so we continue with example 3. Here they give you the equations. An alternating source V is equal to 500 sine omega t is connected across the resistor of 200 and 500 ohm. So number one, calculate the RMS current and also RMS. Okay, so this alternating source is actually connected with the resistor. Okay, so I label it as VR resistor, and this is actually our V source. Okay, so number one, find the RMS of the current and also RMS of the voltage. Okay, so first one, of course, we can find the VRMS here because VRMS is equal to V naught over sub 2. Okay, where V naught here is equal to 500 and over sub 2. Okay, therefore our VRMS is equal to 353.6 volt. Okay, so this is VRMS. Okay, next we want to find IRMS. So as we know, V equals to IR, therefore our IRMS must equal to VRMS over resistor. Okay, because this is only a pure resistor case, so our impedance is actually only resistor. Okay, so we substitute 353.6 over resistor is given 250. Okay, therefore IRMS is equal to 1.41 ampere. Okay, next B, find the peak current. Okay, so we already found the IRMS, so now they ask us to find I naught. Okay, so IRMS is equal to I naught over sub 2. Therefore, I naught is equal to sub 2 times 1.41. Okay, so finally we will get 1.99 ampere for our peak current. Okay, so some books they will use peak current, some they will use maximum current, some they will use amplitude. Okay, so this term is actually referring to the same thing where we want to find the maximum value is actually I naught. Okay, next we'll go to example 4. Okay, example 4 here, they give you the graph where this graph shows that this is actually a sine graph where the I naught here is equal to 0.02 and the period here is equal to 40 millisecond. Okay, millisecond. Okay, figure shows a graph to represent the alternating current passes through a resistor of 10 kilo ohm. Okay, so this one also is a pure resistor case. So number one, find the value for IRMS and also VRMS. Okay, so we can find the first one is IRMS since we have the maximum value I naught. Okay, so IRMS is equal to I naught sub 2, where I naught from the graph 0.02 sub 2. Okay, therefore our IRMS is equal to 1.41 exponent negative 2 ampere. Okay, next we want to find VRMS. Okay, as similar like just now, example 3, V equals to IR. So VRMS is equal to IRMS times the resistor, where IRMS is 1.41 exponent negative 2 and the resistor is 10 kilo ohm. Okay, therefore our VRMS, the value that we will get is equal to 141.42 volt. Okay. Next, we want to find the frequency. Okay, so when you want to find frequency, we know that the period here is given 40 millisecond. Okay, so the frequency F is actually equal to 1 over T. Okay, T is the period. So I substitute inside 1 over T, where T is equal to 40 millisecond. Okay, so we must times power of negative 3. Therefore, frequency of the alternating current is equal to 25 Hertz. Okay, so that's all for this subtopic. We will continue to the next video, 6.3, resistance, reactance, and impedance. See you on next video. Bye.